So last class, we kind of ended with looking at this one sample t-test for the problem where we looked at the number of minutes per hour that's playing for music, that plays music there. And we went through ahead and we had a very small p-value of 0.013. We rejected the null. So that's just kind of the null hypothesis being that, in support of our alternative hypothesis, which is that the mean number of minutes was less than 50 minutes, right? So that's kind of our conclusion. But I asked you to look at the confidence interval in this particular context, and I really want the formula in addition to checking it on the calculator. And what I found when I did this problem is that when I used my rounded answers with the formula, I got a little bit different than what the calculator gave us, but not too far off. Either would be okay, just make sure that you're showing your calculations, that's all, okay? So what you should have gotten when we're talking about a confidence interval, hopefully this notation looks familiar to you, okay? So we have our statistic. Our statistic in this case is x bar, or our sample mean. What does t star sub 11 mean? I'm going to have to use inverse t to find it. That's true. What does the star mean? What's another name for that notation? Interesting. We need to know that, okay? So what is that called? So when you have, it's called a critical t-value, okay? Just like when you have z star, it's your critical z value, or so we have two different things. So this is a critical t-value. What does the sub 11 mean? Degree of freedom, right? It's always one less. So we have this kind of like describes what we're looking for. We have a sample size of 12. Our degree of freedom is 11. And then we have our standard deviation of the sampling distribution, which is just your sample standard deviation divided by the square root of the sample size. So at this time, just by plugging numbers into what we see here, you should have gotten this, which is our sample mean that we got last time. And then we'll find our critical t-value in a minute. Our sample standard deviation, I just rounded to 3 decimal places, and then you have the square root of 12. Do you agree so far? Okay? Looking at my paper, I wrote square root of 11, which is wrong. So that's probably why my values were a little off. But square root of 12, right? Okay. Now, how do I find this, the t? And Chris was saying, I believe it was, or Justin, I'm not sure, Justin said inverse t. I'm sure who said that, but anyways, one of you two. We're going to have to do the inverse to find our critical t-value, right? In the problem, it says a 90% confidence interval, and we have to use that information that's our confidence level, right, to be able to find find our critical value. And if you remember, you put that in the middle, 0.9. Each of the tails is 5%. So we're going to do inverse t of what? 0.95, because it's all the middle plus one of the tails. And then we have to tell it the degree of freedom, which is going to be, in this case, 11. Do you agree? All right. And so what is the critical t-value that you guys got? 1.796. Let's go ahead and try, because if you actually go ahead and plug that into your calculator, we want to try to get as many numbers in that make as much sense. It's hard to, AP is not real specific like IB is in terms of your how well you round. There's no significant figures thing that is very specific to AP stats. But as long as you show your calculations and you're close, they're pretty lenient. Okay, so this is the formula, and honestly, from here, if you just go ahead and write your final answer, that's good. Often on multiple choice questions that pertain to confidence intervals, they will write them in terms of the margin of error, okay? So in other words, if you go ahead and find this value, and mine's wrong because I used the square root of 12, would somebody really quickly just go ahead and plug this into the calculator? If someone already did, that's fine. But would somebody do me that favor real quick and just find this number? Because mine's wrong. I got one. Okay. So oftentimes in a multiple choice, they will give you this answer. okay, where it looks something like this as opposed to the interval itself. We should recognize that both of these last two answers are in fact the same. And this is what I'm giving you here is what the calculator gave me. Hopefully they match up. But these two both mean the same thing, okay? Any questions about that? Now, one of the things I'm noticing when I'm grading your quizzes or looking at some of your homework questions is when we talk about interpreting a confidence interval, a lot of people, or not a lot, but a few people have been saying, well, it captures our statistic. It captured our mean of 47.92. Well, of course it does. It's the center, always. Because if you look at the formula, isn't this the center? Aren't we taking that and then adding and subtracting from that number? So your statistic is 100% always captured in your confidence interval. That's not what we're trying to do, okay? What we're trying to capture is the parameter, right? So that's what you want to be looking for. So in this case, the parameter was what? What was our parameter of interest? 50, right? Because that was the claim from the studio, or the radio station. So does it capture 50? Not only does it not capture 50, because confidence intervals can really give us some real clear-cut information. Not only does it not capture it, but the entire interval is less than 50, right? So that is even stronger evidence to support our conclusion that we came up with to reject the null, okay? And that's what you would say. How do we feel about that? Yeah? Okay. What I'd like us to do is I'd like us to try one more. So go ahead and look on the back for me. I am going to give you 11 minutes. We're going to treat this question on the back as a frappy, as a free response question. If you've already done it, that's okay. But I know that I didn't assign it. If you already did it, that's great. Just pencils down. But I'm going to give you 11 minutes because that's the average time you're supposed to spend on any one free response question, correct? And then we will look at how to answer it and look and see how well we did, okay? So go ahead and try that. I'm going to pause the recording, give you guys 11 minutes, and we'll go from. I want to talk about this particular question in terms of the time that was spent on it and things like that. I told you in this question what to do. On the AP exam, on a true free response question, it's not going to say perform a hypothesis test, okay? What it will say is, does it provide convincing evidence? That kind of thing. And it might say by how much, which is a different question, and we'll get to that in a few minutes. But the directions here told us to do the hypothesis test, right? So part of the 11 minutes, and I probably should have given you less than that, should be to read the problem and decide what to do, right? And oftentimes, from our experience in AP questions, they're very wordy. Do you agree? So this one was very short, concise, and I told you what to do. So honestly, the 11 minutes was probably a little too long. And I did see some of us that were finished before 11 minutes, and that's fine. But kind of give us a, preparation or an idea of how long we should spend. So in the grading rubric that can you exchange papers, by the way? I'd like to try to grade somebody else's paper just to kind of get the idea of what kind of things we're looking for and what would be expected to be on the rubric in a question like this. It's not an embarrassing thing. This is just honestly, when you grade a question, it's just as much of a learning process as if you actually perform to write the question. So just exchange with somebody else so we can try to hunt and peck. There are going to be 3 parts, okay, to this particular grading rubric that we're going to discuss. And this is Mrs. Mackert's grading rubric, not an AP. So this is what, from historically on questions like this is how it's broken down, okay? So in our books, state, plan, do, conclude, we're going to put the state and the plan together in one part, okay? So in part A, we're going to do our state and our plan. If you remember what that means, we're looking for the name of the test, okay? So you must have the name of the test. So we're going to say it's a one-sample t-test, okay? And then you're going to go ahead, and for the grading rubric for our parts, you're going to go ahead and do the null and alternative hypotheses in context in terms of the parameter. So if they just wrote the parameter of interest and then wrote the null and alternative with the symbols, that's totally fine. Or if they wrote the symbols and the words, that's fine too. So we have our null hypothesis, all alternative hypothesis. I'm just going to write the parameter of interest, which was the true speed in a 25-mile-an-hour zone. Okay? Or you could have written it in terms of the null and alternative as well, but we should have that mu equals 25 and mu is greater than 25. If they have all of those pieces, please write an E on their paper. If they are missing one, it's a P. More than one, it's an I. Mike. Mu, that's a P. You have to write the null and alternative in terms of the parameter. That's important. Anything else? Most of us hopefully got E's, right? Oh, yes, Chris. Oh, the alpha. So sometimes it's included in terms of the rubric and sometimes it's not. I actually put my alpha down with the conclude part. But if it's there, that's fine. Okay? All right. So that's your first IEP. PEI? EPI? All right. For part B, it's going to be your do, which I'm looking for your test statistic and your p-value. But look what I'm going to ask that you include. So you must show the work using the formula to find your test statistic. Okay? And then your p-value, I want it drawn. Now, you could have done this with your test statistic. You could have also put 25 in the middle and 28.8 and shaded to the right. So either you have it standardized or you don't. Are we okay with the difference between those two pictures? Both are acceptable, okay? And then you need to do our p-value, which is, and it's again, depending on whether you did the standardized or the not standardized. Either one is okay. You should have gotten something like this. And this is our p-value. Yeah? Good so far? So they need to have all three of those things. I'm sorry, they have to have four of those things, right? They have to have the calculation shown, the actual test statistic, the picture shown, and then our p-value. So 4 things to get an E here. Yes, ma'am. So what happens with the grading rubric on that is they would get a P for that particular error, but that as long as they followed through everything else correctly with that error, they get no more deductions. Okay? Good question. Anything else? Okay. So we should have an E. We should have 2 letters on our paper, right? An E, or an E and a P, or whatever. And then our last part is going to be our conclusion. And in this case, our conclusion, we have... we need to have this exact statement, and again, depending on how you rounded that, okay, any rounded version of that. And here is where our alpha would come in. It's okay if I didn't actually state alpha equals. Some grading rubrics require it, some don't. I'm just going to leave it off here, but it should be part of it. We need to write the words reject the null. And then you have to have a conclusion in context, which is going to be something along these lines. So we have evidence to suggest that the mean speed is greater than 25 miles an hour. Okay? The 3 pieces in order to get an E. If they're missing one of those 3 pieces, it's a P. Any 2 would be a I. All right? And then for part, and that's for all for letter A, right? There's 3 repeats for letter A. And then you have letter B, which is the question, and it's a type 1 error. So you need to say it's a type 1 error. And then you need to explain in context something along the lines. I'm not going to write it down, but maybe the average speed really is 25 miles an hour, but my sample that I collected mistakenly showed that it was much higher. And that's a possibility, right? I mean, it's just my sample that gave me that information, but maybe the true mean speed really is 25. My sample just, I happen to get like, you know, a drag race going on or something in my sample. I don't know, right? Sorry, me and my Prius, you know, who knows? Okay, so that would be a type 1. Why would a type 2 error not even be a possibility here? Because I rejected the null. So it's not an error. That was based on my conclusion of rejecting the null, the only error I could have made here would be a type 1. Okay, so you should have 4 letters on your paper. So let's go ahead and grade it. If you had an EEE, that's a 4. Okay? If you had 3 E's and a P, the P can be anywhere, right? That's a 3. If you had, now 2's get complicated. There's lots of versions of 2's, combinations of E's, P's, and there could be even an I in there. If you had EEEI, that's a 2. Okay. You also can have combination 2 E's and P's. 2 E's, 2 P's would be a 2. Again, in any order. I'm trying to figure out, I think if you have I think an EEPI would also be a 2. Okay? Basically, any 2 E's and at least 1 P in there, it's a 2. But if you have EEII, that's a 1. P is a 1. Okay? Again, this changes depending on each question, but this is a general rule. Sometimes they put all P's in with 2's. Okay? So that could, that could be up here. Do I need to go on for anything else? Like if you have PPPI, I think that would probably be a 1. But anything less than that would be a 0. Okay? Did anyone get a 4? Nobody got a 4? Will you get a 4 by next quiz, by next class, I hope? Yeah? Do we know exactly the steps in the process of what we're looking for? Where do we make our errors? Time? Was the time? Okay. Time. So the good news, go ahead and give your papers back if you would. I'm just going to pause this recording for a quick sec. We should be getting to the point where we are not worried about the steps of the hypothesis test anymore. We know exactly what the steps are. We know we have to name the test. We have to write the hypotheses in the parameter, in the context of the parameter, test statistic, p-value, drawing the p-value, and then a conclusion, 3-step conclusion. Like that should be, at this point, that should be old hat, okay? We shouldn't be guessing that part. If we're still struggling with remembering the steps, we need to practice, okay? So that's what I want you to be working on. Very rarely, I shouldn't say very rarely, but sort of rarely, do you have a full hypothesis test on the AP exam, okay? Often they will give you a p-value and ask you to interpret it. Often they will say, the hypotheses are this, what would you say about this? That kind of thing. It has happened where you've had a full hypothesis test. A couple of years ago, as a matter of fact, there was a full one. Oftentimes it'll be, here's the results of the hypothesis test. Here is the confidence interval. What conclusion can you make? That kind of thing. But very rarely it's all in one. Any questions? Okay, so Hopefully this was a decent exercise for you. You will find that on hypotheses tests, they will have a mixture of things like type 1, type 2 errors, hypotheses tests, confidence intervals, kind of all intertwined. So just kind of keep that in the back of your mind. Go ahead and put this away. This is a good study guide for a one sample t-test. We are going to today look at something called a paired t-test. But before we do, I want to summarize formulas, conditions, and what we know up to this point, and what we're going to add to this. So up to this point, we have done everything with one sample, okay? And today I'm going to introduce a little bit of something that's kind of the bridge between a one sample and a two sample. But let's just kind of real quick just refresh our memory in terms of proportions and means, and we're going to add two samples starting, true independent samples starting next week. Oh, speaking of that, you do have your quiz next class, right? So quiz on 9-3 will be on Thursday. Fair enough? We will go on, we'll kind of review after the quiz on Thursday for your test. I don't want to give you your test, because this is a big test. It covers all of Chapter 8 and all of Chapter 9 the day after a 3-day weekend. So what I thought would be best is that we just kind of go over the quiz next Tuesday that you will take on Thursday. We'll go over the quiz. We'll any questions that you have that came up, we'll look at any kind of, I don't know, free response questions that you had questions about, and then we're going to move on to Chapter 10, okay? So we will start Chapter 10 before your test. I just don't want to give you the test the day after a 3-day weekend. I think that's just trying to, I'm trying to want good grades, right? So just kind of keep that in the back of your mind. So that changes the dates on your assignment sheet a little bit. Just kind of make sure that you're aware of that. The test won't be quiz Thursday and then the test the following Thursday. Okay? There's no snow because it's going to be 70 degrees on Thursday. So crazy. All right, proportions. So we have formulas for proportions, right? We have conditions, and these are all one sample. So we just kind of summarize things for a little bit. Let's just remind ourselves. With proportions, we know we're talking about p hat versus p in terms of our statistic and our parameter. It means we're talking about x bar versus mean, again, statistic versus parameter. With proportions, we also have formulas for our standard deviation. Oops. Our standard deviation of our sampling distribution is going to be square root of p times 1 minus p all over n. And again, we use p hat there if we're talking, that would be the standard error if we're looking at confidence intervals, correct? So confidence intervals only uses our statistics, whereas in hypothesis tests, we're talking about using our parameters to find those numbers. When we talk about means, it's our sample standard deviation divided by the square root of n. Now we can use those numbers, or use those formulas, sorry, if the conditions are met, right? And we know that the conditions, well, let's move those over a little bit. There are 3 of them for each, right? For proportions and means, it's the same for the first 2, right? We have that our sample size is less than 10% of the population. And I'm writing it across because it applies to both proportions and means. We good so far? What's the other one that applies to both proportions and means? The randomization factor. Often it's an SRS, which stands for simple random sample. But we've learned from the last quiz, sometimes it comes from an experiment, which means that the randomization occurs by putting the randomizing into the treatment groups. So I'm just going to write randomization rather than SRS because I don't want us to always fall back on those letters because it does mean something very specific. The third condition is different for both. For means, n has to be greater than what? Greater than or equal to 30, or what? If it's stated as normal, then that means something else. That's true. That means we're going to use z's, right, rather than t's. What's true graphs? We're looking at box plots for outliers. Oftentimes, our sample size is not large enough to show true symmetry with a box plot. When you have a sample size of 10, it might not show perfect symmetry, but we're really looking for outliers in this case. When we talk about the other graph, which is your normal probability plot, what are we looking for? We're looking for linearity, right? Good. When we talk about proportions, we're looking at something different with the conditions. What are we looking for? NP is greater than 10, and again that becomes p hat when we're looking at confidence intervals, right? And n times 1 minus p is greater than or equal to 10. We good so far? Okay. Proportions use what kind of procedures? Like, well, maybe you don't know that word. Normal procedures, Z procedures, that's what it's called. We use the normal CDF to find our p-value. When we talk about means, almost always we use T's. Do you agree? When don't we? That's what Keverlin was saying. When you're given the population standard deviation, which is very rare. But it happens. So that's kind of a summary of our one sample situations. Okay? We are going to now add 2 samples. But before we do that, we're going to look at a special case called matched pairs. And matched pair t-test is something that we're going to do underneath means. And there are 2 samples that are taken. They are just matched somehow. So we're going to collect our own data here with all of us. And we're going to collect resting heart rates versus standing heart rates between us. And we're going to talk about doing one sample, and then with all of us sitting, and then another sample with all of us standing, and we're going to look at that. Now, do you agree that it's 2 samples that have been collected? The before and after, oftentimes we call it, right? We're going to look at various scenarios of when these samples can be matched. The question I'm going to ask you is there a difference between standing heart rates and sitting heart rates? So let's think about our state, plan, do, conclude. What would our, before we collect our data, what are we going to state to begin with? What do you think, Mike? The parameter of interest, okay? So what is the parameter of interest here? Be very careful. So I'm going to ask the question one more time. Sorry, Nick, I didn't mean to cut you off, and I'm going to let you answer it. The question is there a difference between standing and resting heart rate? Sorry, Nick, I didn't mean to cut you off. Go ahead. Yeah, you're going to have to look at the difference between the 2. If there is a difference, that's your clue. You're going to do some subtraction. If there is no difference, what would the difference be? 0. So when we think about looking at our ho and our ha, I still have to play you my statistics song. I haven't done that yet. It's by the Lumineers. Okay, but I call it ho ha. Get it? Ha ha. Funny. All right. Anyway, this would be, look at the notation. The difference is 0. That's a D, by the way. Mu sub D. That's one way to say it, and that's acceptable. The other way you could say it is that the mean of, which one do you think is going to be bigger? say standing minus resting is equal to 0. Wouldn't that be the status quo, right? There is no difference between resting and standing. What would the alternative be? And then we're going to come back, Mike, to what you said in terms of the parameter. What do you think? Do you think it's going to be higher or